Good afternoon, everybody. Today, we're going to talk about problem 3 of the January 2023 contest, the platinum level. This is a tree problem. So we like trees. So the problem is you basically have a tree. For easy drawing, let's make it a binary tree. So then there are, let's say, light bulbs on the tree. And you basically want to activate every sub-tree of this whole tree, and then turn it off and activate every other sub-trees in a recursive way. Let's put it this way. So the question is, every time by turn on and off every light bulbs on it. So the question is, in total, how many times you need to do this? So in this example, right, so we have, for example, we have 3 nodes. Node 2 is attached to node 1, node 3 is attached to node 1. So you have node 1 and node 2 and node 3. The way you do it is you turn this on, and then you turn this on. So this branch, right, is this subtree is activated. Then you turn this on, so the whole thing is activated. So then turn this off and turn this off. So this thing is activated, right? So this branch is sub-branch is activated. Then you turn it off. So that's total, right? 6 times. So how do I do this problem? If we just look at how we did it here, we can use a DP, right? Seems like we can use DP. So if I know the answer here, how do I get the answer here? That is a problem, right? The transformation of the DP. That is the problem we're trying to solve. Frankly, this is, I don't know why it's problem number 3. To me, is the easiest of the 3 problems. Okay, let's define DP0 is what the problem is asking, right? So it's all the sub branch, let's say DP0 of I, right? Means the answer to this problem, with the the parent is at I, meaning the initially is not activated. You do a bunch of work. At the end of the day, everything is also turned off, right? Initial is off. Let's do this way. Initial is off, and the end is everything is also off, right? So let's see, how do I do this? If I just follow what we just described here, let's make it easy. Let's assume there's only 2 child. Okay, you could have multiple child, but the same thing. 2 child, you can, as we said, we can turn this on, right? And then we can turn this on and this on, and then we turn this off, right? So turn this on means we need to have, initially it's off, right? We make it on, okay, and then we turn this on, it's +1, right? And then we turn this off, right? Then we turn this on, right? Initially is again off to on, right? Off to on. Okay. Now you turn this on, you activate this branch, right? If you turn this on, which is +1, Then you turn this on. Now the whole thing is activated. Now you have to turn this off. Turn this off is one more action. Then you have to turn this off. Then you have to get on to off, right? Then you get this, right? Then in the end, then you turn this off, right? Turn this off is, right, from on to off. Right? So now seems like we need, in order to calculate this whole thing, okay, dp of 0, right, which is the one we need to have two other states. Dp of 0 of I. So we need to have another one. Let's call it dp1 of I, which is the initially is off, right? Initially is off, just like the original problem. But in the end, let's make all the node in the subtree on instead of turning it off. Just make it all the way on, or everything's on. Okay. Then you need another one. Let's call it dp2 of I, which is initially every subnode is on, and then I do all the activity, same activity as I described, but in the end, I have to make it off. Right? So again, so let me explain. So our initial problem was every node in the subtree of I, every node is off, then you do all the activities for that subtree, right? Turn each subtree on and off. At the final stage, every node has to be off. Okay, so dp1 is the initial stage is the same, and you do all the actions as the problem described, but in the end, you leave everything on. dp2 is opposite. The initial stage is everything's on. You do everything you want, but in the end, you leave it off. Okay, so that's if you follow this path, right, then I can use dp1 and dp2 to calculate dp0. But there's another way to do this. Okay, so this is one approach. Right? There's another approach to do this, which is, you have the child, right? How about for every subnode, I do exactly what was described. You make it off, and you do all the actions instead of keep it on, you make it off. Okay. Then the only thing left is the only state that is not. If you do this, right, everything can be calculated from dp0. Right? I mean, let's call it J, which is sub of that. Everything can be calculated from here. The only thing is not covered is turn the whole thing, right, in the subtree on, and then turn it off, right? So how do you do that? Is, let's say you have multiple. If let's say this is the biggest one, you take the biggest one. For the biggest one, I mean, if you have a multiple, right? For the biggest one, you don't do this because that wastes too much, right? For the biggest one, when it's off, you keep it on. Okay, at this stage, then you turn everything else on. Okay, then you turn it off. Okay, so let me try to explain this. Use that example I have here. 1, 2, 3, right? So one pass A is I turn this on, so this branch works. Then I turn everything else on, the whole thing works. Then I turn those off, so this covers the sub branch. The other one is I turn this on. Let's say this is the biggest. There's a bunch of things there. Turn this on, and then I turn this on, and turn this on. I basically make that whole thing. Then I turn everything off. Then I calculate other branches. Okay. So then you just need right? What is the minimum of A and B, right? Those two scenarios. Then you solve that. So I basically broke the problem into two subproblems. How do I calculate the DP1 and how do I calculate the DP2? That is actually a little bit easier and actually much easier than how to calculate the original DP0. So let's look at the DP1. Okay. DP1 of J is everything is off. I need to make it on, right? So this is J. Okay. The way you do it is for every branch you make it off, right? And end with off. That was my DP0 of that branch, right? And then you turn everything on in the end. That is basically the size of that thing, right? Of that branch. Okay. Then everything will become on. The only thing you need to deal with is how do you turn everything, right? Everything on. That is the same trick as this. When you find the biggest branch, right? For the biggest branch, you don't do off to on because you waste your time, right? You just for the biggest branch, you just do off on. Remember which was the DP1 of this thing, right? Then for the biggest branch, you do off on, right? And then you activate everything, so you make this on. For everything else, you do off on. Okay, so that's DP1. DP2 is the same thing, except, I mean, DP2 of J is the same thing, except that you do it opposite, right? Because it's on, you want to make it off. Initially it's on, you make it off. You do the same thing, except that you deal with the one differently. Meaning, for each branch, you turn it on first, right? Then you do it's on first, right? Then you first turn it off, which is the size of that tree, right? Of that branch. Then you do all those things as described in the program. Then you, in the end, make it off, right? So this step is DP0, right? So you turn it, you have to turn it on, which is the size. I mean, it's on. Then you have to turn it off, everything off, which is the size of the subtree. And then once it's off, then you do off and then do all the activities and you turn off. That's DP0. And you do it, then only treat the special, right? The biggest sub branch and specially. Okay, so that's easy, right? So now you can calculate DP1 and the DP2. Once you can calculate DP1, DP2, then you do then your DP, right, reverse bottom up of the tree, then you can calculate the DP0. I think the only special case is what if you only have one branch and one child, right? You have one child, it's easy, right? If you only have one child, you just take this DP0, right? The only difference is this thing, right? You have to do it twice, right? Basically, this child of your thing, you have to +2, right? Because remember, you have to turn it on and you have to turn it off. Then for DP1, you only have to do it once, right? Because it's from off to on. This has to go off to on to off, right? Twice. DP1 is once. DP2 is also this child +1, right? Because you only from on to off once. DP1, you only go from off to on once. Okay, so that's a special case if it's only one child. So then just simply doing this DP, you can get the result, and it match because you're DP it, right? So you actually meet the time limit. So that is actually a relatively easy solution, and I think is actually easier than the published solution. At least it's easier for me to understand it. So that's how we did it. So now we finished all the 3 questions for January contest. So the next contest is going to be a month. I'm sorry. As we are speaking, right? So hopefully you are having a good time for the 3rd contest, from the Friday to Monday, and then good luck with your contest this weekend.